Hey everyone, this is Miss Gallen. I'm going to be going through this introduction that you started in class on either Thursday or Friday, depending on which day you have your second honors geometry class for the week. So I'm going to be going through this from the beginning. I know you may have started this, and that's fine. I encourage you to watch it all the way through to make sure that you truly understand this. And as well to follow along. So I encourage you to have your Kami sheet open because you will be turning this in after. So think of this almost as a video answer key. Yeah, that's what I'm going to call it. So at the end of the video, I'll be sure to show you how to get the share information and explain exactly how you're supposed to share it with us so that we're able to see it and we don't have to request any access from you. So in this lesson and what we're looking at now, we spend a lot of time with rigid transformations, is we're going to be combining transformations, which is better known as a series of rigid transformations. So what that means is we're taking what we know, transformations. We're taking what we know about translations, rotations, and reflections, right? Those are rigid transformations, and we're going to build one off of another. So instead of going back to the original pre-image each time, we're going to be building, and we're ideally going to be able to write a rule or a coordinate notation for, like, it's something that's going to take us from the very original pre-image, so like what we start with, all the way to the final image. So this one has a lot of steps. This one's a little, I don't want to use the word excessive, but this one combines a lot more than you might typically see. Like you might be doing a reflection and then a translation, or a translation and then a rotation, and that idea. And so this is obviously, we've got 5 steps going on here. So it's a lot. All right, so I'm going to choose to use different colors, and what we're going to be doing is we want to plot and label on this graph over here. We want to end up with all of our pre-images and images, and as well as like the very final image. We want to end up with it all over here, and it can get messy, so I'm going to choose to use different colors. I encourage you to do the same. And we're going to be writing the coordinate notation for that specific direction, that specific verbal description, as well as the one that would take me from the very pre-image to whatever that new image would be. So we're going to start off, and I'm going to just do it in green. And we're going to plot and label this. So -2, 0. We've got A, -1, 3. We've got B, -4, 7, and maybe label it as you go. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. What did that C? And then D is -5, 1, 2, 3, 4. So I've got this nice quadrilateral here, and I've labeled it as I went. All right. So great, we've done that. I'll check it out as I go. Now I'm going to use pink. So now I'm going to reflect that quadrilateral across the x-axis. So this right here is our x-axis, and so that means that the distance from that line of reflection is going to be the same. I'm going to be on the opposite side of that. So actually A is not going to move. I'm going to write the rule after. So this would be A prime. B, 1, 2, 3, 1, 2, 3. Maybe you're somebody that memorized the rules and you want to do this a different way than me. That's fine, as long as you end up with the same final image or the same next image. 2, 3, 4. 1, 2, 3, 4. This is D prime, and then this was 7 above, so 1, 2, 3, 4, 5, 6, 7. And it should look exactly the same, right? These two should look congruent to one another. If they don't, I must have made an error. So I should be able to fold it. Mine's not the most pretty thing I've ever seen, but I should be able to fold it on this line. Like if I was holding an actual piece of paper, if I folded it on the x-axis, those points would map onto each other. C would lay on top of C prime. D would lay on top of D prime. So then I've done this one, right? So this individual coordinate notation, and maybe you're not someone that has it memorized, you always start with x, y, and then what happens to it. Well, if this was -4, you know what? Let's write up. This was -2, 0, and it's still -2, 0. Maybe not the point I want to use. B prime, -1, -3. So maybe you're seeing what happened here. It went from -1, 3 to -1, -3. C is -4, -7. right? That was -4, +7. D prime was, I'm sorry, D prime is -5, -4. So your X values are staying the same and your Y values are becoming opposite. Since this is our first one, it's just XY becomes, you know what? Actually, I have a better idea. I'm going to do this one in green because that's my original one. And I'm going to do that for all of these so I remember which color I'm going from, because I'm going to use a different color for every single one. Right? And that's how we always start it. So even if you're not sure, you always have this written. It's like an equation. You write at least y equals. So to get from the pre-image, the green one, to the pink one, I am doing X is staying the same and Y is becoming opposite. So we just have to remember going back to the green one when we do the next, like when we write the coordinate notation. So I'm going to go ahead and I'm actually going to do blue for this next one. So I'm now going to be transforming this new pink one, my new image. So this one tells me I'm going to go 2 units right and 7 up. So 2 right, 1, 2, 3, 4, 5, 6, 7. Labeled as you go. This is A prime. 2 right and 7 up. 1, 2, 3, 4, 5, 6, 7. Isn't that a game? 1, 2, 1, 2, 3, 4, 5, 6, 7. Oh man, it's right. So there's a lot of overlapping in this. So this is where I want to be neat and I might want to use different colors. 1, 2, 1, 2, 3, 4, 5, 6, 7. Oh my God, another point there. But now it's no longer A prime. You know what? These are double primes, aren't they? To indicate another transformation. And there, oh, I didn't love that, but that's fine. Okay. So let's see, let's write our point. So A double prime is now 1, 2, 3, 4, 5, 6, 7. 0, 7. It went from -2, 0 to 0, 7, right? We're going to go back to that green one. That's why I wrote it in green. B double prime is 1, 1, 2, 3, 4. 1, 4. C double prime is -2, 0. D double prime is -1, 2, 3, -3, 3. Right? So think about what happened. This individual rule would be XY becomes X plus 2, Y plus 7. So, but it's building off of this. I have to remember that I wanted to go off of this one. So my X is going to stay the same. I'm sorry, my X is just going to have 2 added to it. Right? I'm going to build off of this. X plus 2. You're basically doing this to the one that came right before it. -y is not going away. -y plus 7. And let's check that that worked. Well, if I do -2 plus 2, I get 0. If I do -0 plus 7, I get 7. -1 plus 2, I get 1. 3. -3 plus 7 is 4, right? Like you need it to work for every single point. But notice I'm writing a coordinate notation that takes me from the very first to the very last. That's my goal here. Let's do step 3 in purple. So for this one, I'm now going to take this blue one and I'm going to rotate it 180 degrees. So maybe you're someone that needs to turn your paper around. Maybe you need to draw yourself a picture of it. But I know, let's say, whatever I do, I get my rule is -x, -y. I'm going to negate both my coordinates. So what was -2, 0, I'm going to spin that around, right? It's 180 degrees clockwise. Wouldn't matter if it's like counterclockwise about the origin. This point right here is C triple prime. This point, I'm going to spin it around. It was 1, 4. Now it's going to be -1, 1, 2, 3, -4. And that point right there would be B1, 2, 3, 4, quadruple prime. Or is it triple prime? Triple prime. Miss Gallen. Let's see, where am I now? D. So -3, 3 becomes +3. 1, 2, -3, right? You're spinning it around. That's going to be D, 1, 2, triple prime. And then finally, A was 0, 7, so it becomes 0, negative 7. 1, 2, 3, 4, 5, 6, 7. Right? And I can connect it. It's already labeled. And this should look exactly the same, but it was just spun. Right? Like A ended up down here, B ended up. So it's like the same thing, but upside down. If I took this paper and literally flipped it upside down, I would be looking at what this purple one is. So what happened here was I'm literally going to negate my X and Y coordinate. But you have to remember that we've already done some stuff with it. So I'm going to negate X plus 2. That's negative X minus 2. And I'm going to negate what I had up here. Well, that's going to be positive Y minus 7, right? You're literally just negating everything. Let's make sure that that worked. So C triple prime was 2, 0. D triple prime was 3, negative 3. B triple prime was negative 1, negative 1, 2, 3, 4. Ooh, excuse me. Negative 1, negative 4. And then A triple prime was 0, negative 7. So I just want to check that this worked. If I go and I plug negative 2 in here, negative 2 is just 2. 2 minus 2 is 0. If I plug a 0 in here, 0 minus 7 is negative 7. Perfect. A triple prime worked. Let's try B triple prime. They've all got to work. So negative 1. Negative 1, that's just 1. Minus 2 is negative 1. Perfect. What about the Y coordinate? 3. 3 minus 7 is negative 4, right? And so I could check the rest of them, and it's a rule that works for every single point. I'm building here. Okay. We're almost there. Oh, no. Oh, boy, look at all these choices. I'll go with orange. Oh, that is certainly not orange. There, we've got an orange now. Okay, so now we're going to take that purple one. This is going to get messy, my friends. And we're going to reflect it across the y-axis. 1, 2, 1, 2. Oh my gosh, how much stuff is over here? So that's going to be C, 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. That's D, 1, 2, 3, 4. Maybe I should be writing these as I go. This was negative 2, 0. D was negative 3, negative 3. Okay. A, oh, that's not going to move. It's on the line of reflection. So 1, 2, 3, 4. 0, negative 7. And then, oh, this is going to be interesting. So I've got to go 1 in this direction. 1, 2, 3, 4. I certainly hope you guys are using different colors, or else this is going to be real confusing. This is why we spent so much time working with single ones. 1, negative 4 is that we've got here. So this rule alone, I would start with x, y, and it would become, well, my x would become opposite, and my y would stay the same, right? Like this was 2, 0, and then it's negative 2, 0. This was 3, negative 3, and now it's negative 3, negative 3. My y's are staying the same. My x's are becoming opposite. So let's apply that to what we had right back here. My x is going to become opposite. And remember, when it comes opposite, the entire thing becomes opposite. So I'm going to get x plus 2, right? Negative x minus 2, negate the entire thing. And y is going to stay the same. So y minus 7. Let's double check that. So if I plugged in, let's check it with D, negative 5. Negative 5 plus 2 is negative 3. 4 minus 7 is negative 3. How cool. You can confirm as you're going if you're doing it right. I need one more color. Have we done a red? I don't think so. That's not red. Why does it do this to me? All right, so this last one, we're going to translate that orangey one that we had in there. Right 4 units. 1, 2, 3, 4. Oh my goodness. So that is C. 1, 2, 3, 4, 5. What's that? 2, 0? Let's write it as we go. And then this one. 1, 2, 3, 4. I just moved B. 1, 2, 3, 4. A. 1, 2, 3, 4. I thought I was going to write it as I went, and then I forgot. It's okay. So this was 1, 2, 3, 4, 5. 1, 2, 3, 4. 5, -4. A is 1, 2, 3, 4, -7. And then D, where is D? Right here. 1, 2, 3, 4. Oof. Right? So at no point do I have a different shape. I have that same quadrilateral. It's just like moved all over the place. So that was 1, -4. So this move alone, I would be going from x, y, and if I'm going forward to the right, it would be x plus 4, and y would stay the same. Remember, you're applying that to this right here. So you're going x plus 2 plus 4, which is just x plus 6, and then your y value is not changing, y minus 7. And so then we can check that, right? Did I just, if I did B, if I plug in a -1, -1 plus 6 is 5. If I plug in 3, 3 minus 7 is -4. So you can confirm it with those points. And this is what I end up with. So this, I just did a ton of different transformations. I built off of it. I did a series of rigid transformations. And this is the coordinate notation that is going to take me from the very first point to the very last point. So notice I'm not going step by step with a bunch of arrows in between. So you might be looking at this and being like, wait a minute, that's another transformation that I know about. I could have done that one 2 weeks ago, right? So is there a transformation or a combination of transformations that would map the image from step B? So I'd like to highlight. I don't know if that's a possibility. I don't know if that's a thing. Let's see if I can get it. I think that makes it more transparent. So my very first one is right here. My very last one is right here. So I'm going from the green to the red is what I did. And then this question is asking me, is there one that would take you, map step 5 back to step 1, back to the original one, right? So is there something that's going to take you from this red one to this green one? Well, you could, and remember the importance of using the terminology, you could translate left 6 units and up 7 units, right? There's a single transformation. To go from the pre-image to the very final image, all we're really doing, we did all that work, and all we're really doing is going right 6 and down 7. We could undo that by translating, don't leave that word off, please, right? We want to know what rigid transformation or which rigid transformations you're using. And it's a translation of a left 6 and up 7. Left 6 and up 7. It works for every single one, right? So this is like an introduction to the series of rigid transformations. This requires some work and thinking, and it is a bit complicated, right? And so in addition to having you work through this and watching this, and checking your work against the answer key as well, you're also watching a video introducing series of rigid transformations and submitting your notes to us, because we really want to emphasize how important your work in this concept is, because this is really, you're not really learning anything new per se, but you're really applying so much that we've done over the course of this first topic. So with that being said, if you need to go back and rewatch anything, I encourage you to do that if you need to pause at different places. But hopefully this helped you to begin to think about series of rigid transformations. And if you haven't already done so, that you watch that video lesson. What your job, once you finish your worksheet, right, so you're doing this on your own, Cami, is you have to submit it to us. And in order to do that, you have to go right up here to where it says share document. And I'm going to I want you to make sure that you have, it says anyone with the link, and then you have it say editor, and then you're going to go ahead and copy it. And when you've copied it, you'll go into the assignment and submit a link to this. So that is how you will submit your copy of this assignment to us. So thank you everyone for watching, and I will see you next time.